All right, are you ready to crack open the circuits handbook and see what makes this thing tick?
You know I am. Last time we left off, I was ready to start building my Rec Room masterpiece, but we need to figure out how these circuits actually work first. It's all visual programming, right? Like connecting the dots, but with digital components instead of crayons.
That's a great way to put it. It's like you're not just playing in Rec Room anymore, you're shaping the world itself.
Shaping the world, huh? I like the sound of that. But
Yeah.
how does it actually work?
Well, you have to understand, Rec Room actually has two layers. There's the regular Rec Room world you see, the room layer, they call it, where you hang out with friends and all that.
Okay, that's what I'm used to seeing. What's this other layer then?
The circuit layer. It's like this hidden world of creation, and you use the maker pen to reveal it and start building.
Hold on, so I have to put on my developer X-ray goggles or something to see these
That's a
circuits?
good way to think about it. And there's a good reason for this separation, too. It keeps the player experience nice and clean, even if there's some crazy stuff happening behind the scenes.
That makes sense, yeah. I can play a game without accidentally messing with the game logic or something. But there are still circuits running and making all that happen, even if I can't see them.
Exactly. And those circuits, they rely on a few key concepts. The Circuits Handbook calls them out right away: syncing, execution, and heat.
We already talked about syncing, right? Those magic antennas, making sure everyone's seeing the same thing.
You got it. Positions of objects, scores in a game, even just the color of a light rec room is constantly sending out messages to make sure everyone's on the same page. We're talking hundreds of these messages every second.
My brain hurts trying to picture that. Okay, so syncing keeps things consistent. What about this execution thing? Sounds important.
That's where the rubber meets the road. It's
Yeah.
like sending electricity through the wires of your circuit, making everything activate and do its thing. But here's the wild part. It's not just happening on some server far, far away. It's happening on players' devices.
Wait, so my computer could be running part of a game that someone else built. That's kind of trippy.
Yep. And it makes circuit design pretty interesting. Sometimes you need things to happen instantly for a player, like when they press a button. Other times you need one player's device to take charge for everyone, managing things in a more centralized way. It all depends on the kind of experience you're building.
I bet that's where the GM pattern comes in, right? We talked about that briefly earlier.
Exactly. But before we get to that, we got to talk about heat.
Heat. Please tell me my computer isn't going to burst into flames if I build a really complicated circuit. My cooling system can only handle so much.
Not literally, but it's a good way to think about it. Heat in circuits represents how much they're pushing your system, how much network bandwidth they use, and how much processing power they need.
So if my circuit's trying to sync a million things at once or do some crazy calculations, it's going to generate a lot of heat. Got it.
Right. And just like in real life, too much heat is a bad thing. It can slow things down, create lag, even make the whole thing crash. So as a circuit creator, you got to be mindful of how much heat you're generating. Think of it like being an energy-efficient engineer, trying to make your creation as lean and mean as possible. Now, are you ready to meet the building blocks of this system?
Let's do it. What are we working with here? Digital Legos, you said?
Kind of. The Circuits Handbook divides everything into four main categories: Rec Room objects, chips, boards, and components.
Okay, let's start with the familiar Rec Room objects. I'm guessing those are, well, the objects in Rec Room, right? Makes sense to me.
You'd think so. And yeah, you've got your doors, buttons, balls, all that stuff.
Yeah.
But when you start using circuits, those everyday objects get a whole lot more interesting. They're not just decorations anymore.
So that button I see in a game isn't just a button. It can actually trigger a whole chain reaction in a circuit.
Precisely. Suddenly, pressing that button in the room layer sends a signal that the circuit layer can listen to and act on. It becomes an input, setting your logic in motion.
Okay, that is officially cool. So the objects are like the triggers. What about those chips you mentioned? Those sound like the brains of the operation.
Bingo. Chips are your logic gates, the decision makers in your circuit. They do the math, compare values, store information, all that good stuff.
So if I wanted to build a circuit that keeps score in a darts game, I'd use chips to add up the points every time someone hits the target.
You got it. And you can chain these chips together to create really complex logic flows like, if this happens, then do that, otherwise do this other thing. It's like a flow chart, but with digital Legos. Now imagine you start building a really complex circuit with dozens of these chips all wired together. Things can get pretty messy, right?
Yeah, I'm already picturing a tangled mess of wires and lights, my worst nightmare.
And that's where boards come in. Think of them like containers for your circuits. You can group related functionality together, just like you'd organize your stuff into different boxes or drawers.
Oh, so instead of having a jumbled up mess of chips and wires, I can have separate boards for different parts of the game logic. That's way more organized.
Exactly. There are different types of boards for different purposes, but they all help to make your circuits cleaner, easier to understand, and even reusable.
Yeah.
It's all about that good design, you know. Now for the final piece of the puzzle, components.
Components. Okay, I'm picturing some kind of high-tech gadget with blinking lights and buttons. What do they do?
Not quite, but I like your enthusiasm. Components are the bridge between your circuits and the actual things that happen in the Rec Room world.
So they take all that logic from the chips and boards and translate it into something players can actually see and hear.
Exactly. There are components for playing sounds, creating visual effects, moving objects around, triggering animations, the whole shebang. It's like having a magic wand that can control the very fabric of Rec Room.
This is blowing my mind. So we've got these four pieces. Objects that trigger events, chips doing the thinking, boards keeping things tidy, and components making stuff happen in the game. But how does it all work in practice? Can we see an example?
Of course. Remember our button and light example from before. Perfect way to see this in action. We've got player A and player B hanging out, and player A decides to press a button.
And because Rec Room's got that awesome syncing, both players see and hear that button press happening in real time, right?
Exactly. But now, here's where the circuit layer magic comes in. That button press triggers an output, but it only fires for player A, the one who actually pressed it.
Okay, so we're talking about that local player execution you mentioned. It's happening on player A's device, right?
You got it. And that circuit, running on player A's device, activates a light component.
Hold on a second. Player B still sees the light turn on, though, right? Even though the circuit itself only ran on player A's device.
That's the beauty of it.
Yeah.
Even though the decision to turn on the light happened locally, the result is synced globally. Both players see the change because the light component itself is synced.
That's so clever. So it's a balance. Local execution keeps things running smoothly, and global syncing makes sure everyone stays in the loop.
You're getting it. And that simple button and light, that's just scratching the surface. This whole system with the GM pattern and everything, it lets you create some seriously complex and impressive stuff.
I can only imagine. Okay, you mentioned this GM pattern a couple of times now, and I'm dying to know more. It sounds like it's the key to unlocking even more potential with these circuits. Welcome back. I feel like my brain is doing a little syncing and heat management of its own after that last section.
It's a lot to take in, but you're catching on quickly. We've covered a lot of ground, from the fundamentals of how Rec Room keeps everything in sync to the intricacies of building with circuits, and now we're about to unlock even more creative possibilities with the GM pattern.
Right. Last we left off, you were about to reveal the secrets of this GM pattern. It sounds like something straight out of a Game Master's playbook, but we're talking about Rec Room here.
It's a fitting analogy. The GM pattern is a powerful way to design circuits that are robust, reliable, and can handle the unpredictable nature of a multiplayer environment where players are coming and going. The Circuit's Handbook gives a great example using a countdown timer.
Okay, I'm picturing a big digital clock ticking down in a game. What's so special about that?
Well, imagine building that timer without the GM pattern. You might tie the countdown to the local player who started it. Seems logical, right? But what happens if that player leaves the game?
The timer just stops. That would throw the whole game off.
Yeah, exactly. It'd be like the referee walking off the field mid-game. The GM pattern solves this by assigning a very important role to the room authority player. Remember them.
Right. They're like the designated driver for the whole room, making sure everything runs smoothly. So are you saying they become the official timekeeper?
Precisely. With the GM pattern, the room authority player takes responsibility for managing the timer. No matter who comes or goes, the RA makes sure the countdown continues. It's like having a dedicated stage manager behind the scenes ensuring the show goes on.
That makes so much sense. It's like that saying, the show must go on, but for Rec Room circuits. I bet this pattern comes in handy for all sorts of complex creations.
Absolutely. Think about a game with a scoreboard, or maybe a system for spawning enemies at regular intervals. With the GM pattern, you can offload those critical functions to the room authority, ensuring they remain consistent and reliable no matter what's happening with individual players.
It's like building in a safety net for your creations, making them more resilient and less prone to breaking when the unexpected happens. This is all starting to come together. But I have to ask, with all this talk about the circuit layer and these powerful tools, are there any limitations?
That's the beauty of it. Rec Room system is incredibly flexible. The execution model, combined with the GM pattern and all these circuit components, allows for both fine-grained control and global coordination.
So I can create a game where players have precise control over their own characters or actions while also having global systems that manage the overall experience.
Exactly. Imagine a racing game where each player needs to steer their car, but there also needs to be a system for starting the race, tracking lap times, and declaring a winner. The GM pattern could handle the global elements, while local execution manages each player's car. It's like a symphony orchestra where each musician plays their part, but there's a conductor keeping everything in sync.
That's a fantastic analogy. Okay, last question. For those listening who are feeling inspired and want to dive into the world of Rec Room circuits, what advice would you give them? Where do they even begin?
The most important thing is to just jump in and start experimenting. Rec Room is all about play and exploration. Don't be afraid to tinker, experiment, and see what happens. There are tons of tutorials and resources available, and the visual nature of circuits makes it very approachable.
It's like learning any new skill. The more you practice, the better you get. And the Rec Room community is incredibly supportive. It's a great place to find inspiration, ask questions, and share your creations.
And as you start building more complex creations, remember the principles we've talked about today. Syncing, execution, heat, and the power of the GM pattern. These concepts will help you design circuits that are robust, efficient, and fun to play.
This whole deep dive has been eye-opening. Who knew there was so much going on beneath the surface of this seemingly simple VR world? It's like discovering a whole new dimension of possibility.
It's a testament to the creativity and ingenuity of the Rec Room developers and the incredible community they've fostered.
So, to wrap things up, whether you're a casual Rec Room player or aspiring game designer, we encourage you to dive in, explore the power of circuits, and see where your imagination takes you.
And remember, the only limit is your own creativity. Who knows what amazing experiences you might bring to life? Thanks for joining us for this deep dive into the world of Rec Room.